Welcome back to another exciting chemistry lesson. In the previous lessons, we learned how to multiply a conversion factor or more than one conversion factor to start from a given all the way to an unknown. And basically, when we multiply conversion factor, we cancel out unit. Now, in this lesson, we are going to look at how the conversion factor work together. For example, if you look at this side A and side B, it's pretty much the same, right? The reason why we have A and B because we are going to deal with two different chemicals, and one chemical represented by A and one chemical represented by B. And you also, right here, you also have something called STP, and that is standard temperature and pressure. The temperature is equal to 0 Celsius, and the pressure is equal to 1 atm. So keep that in mind. Now, if it's not a standard temperature, you have to use this equation. So in your problem, it will tell you relative is STP or not. So this is where the tricky part is going to be. Now, this flowchart allows you to visualize how things are connected together. Before, I just gave you the conversion factor and you put them together, but now you can see how they are related together. And notice how everything is related to mole. And once you have mole A, you convert to mole B easily. And that is the only way to do it, is using mole A and mole B through mole ratio. And you know, the mole ratio is in the coefficient of the chemical equation or the subscript of a chemical formula. So let's go down here and do a practice problem. As for your lesson, you are going to draw this flowchart on your notebook, and throughout the year you are going to memorize it, and you are going to use it so often that you are going to remember forever. Okay, now let's look at this problem. Here we have the stoichiometry flowchart, right, and a balanced chemical equation. Okay, in this balanced equation we have one nitrogen gas, 3 hydrogen, and that produces 2 ammonia. And in addition, it released 92 kilojoules. Now, with that information, let's continue to read the problem. How many grams of ammonia, right? So, if you notice this one here asking us for how many grams, that's a question mark, is produced from a given grams of nitrogen. What happened? The chemical is different, right? So, we have to realize that. Notice I use the term given. So, in this case, we are giving a generic. In this problem, notice I didn't give you a specific number because I used the term given. So we are going to, if we continue, if we have two chemical, we assume A is the given chemical, B represents the unknown. So do we have two chemical? Yes, 1, 2. So we are going to label this A and this is B, okay? So again, this is a review lesson. It looks different, but it's the same process. Now go back up and look for grams. Where's grams of A? So grams of A is right here. So that is your given, okay? And we are going to multiply until we get to our unknown chemicals, which is B. But specifically what B is grams of B, which is all the way over here. So how do you get from here to there? Again, the only way you can do is multiply conversion factor. Look at the arrows, double direction. That means you can go this way, okay? You can go that way, and you can go up there. So we have 1, 2, 3, and the order of the conversion factor has to be the same way it's presented on the flowchart. So we are going to multiply by 3 conversion factor. 1, 2, 3. Now let's go back down here and solve the problem. The solution will have the given, right, which is in this case right here, time blank conversion factor in the order of. So in this case, how many conversion factor? We have 1, 2, and 3. So we have 3 conversion factor. So here we have our given in this case, okay? So our given is gonna time what? The first one is 1 mole of A equal to the number of grams of A. Now what's the next one we have? Number of mole A equal to number of mole B. Did you see how that worked? Did you see how that works? The order has to be exactly the way it is, okay? And I'm going to show you this problem by not having a specific number into it. And then the last one is 1 mole B equal to the number of grams B. And I'm going to illustrate that to you by just taking our given. What's our given? Our given is grams of A, right? So we have number of grams of A time. If we look at conversion factor here, which one go on the bottom? Of course, the number of grams of A on the bottom. If grams of A on the bottom, this has to be on top. So 1 moles of A. See how grams of A cancel out? Now we move on to the next conversion factor. Okay, if this is mole A, which one's going to be bottom? Of course, the number of moles of A is going to be on the bottom. And then the number of moles of B is going to be on top. Look what happened to mole A, cancel out. Now we're on our last conversion factor. This is moles of B, so down here, of course, the 1 moles of B is going to be on the bottom, and the number of grams of B is going to be on top. And look at that, I can solve this mentally without having the actual number right there. So now, what do I have? I just multiply everything on top, and your answer would be somewhere in grams of B. Okay, so that's the logic behind using the flowchart. As you are practicing with this, the goal is to help you memorize it. Eventually, we're going to solve a problem with it, okay? So the first step right now is just memorizing the flowchart. Now let's solve a problem. How many liters of ammonia is produced from 23 grams of hydrogen gas, H2 as STP, and we are given our molar mass. So here again, we have two different chemicals. And what is our given? Our given is grams of hydrogen gas, okay? So if we go back up here, gram of hydrogen gas is right there. That is our given, right? And what are we solving for? We're solving for how many moles of ammonia. So because the chemical is different, see how this H2, this anode, NH3? So that means we are going all the way over here. So this is our question mark. We are trying to solve for it, okay? To do that, what do we have to do? We have to go down. Okay, again, follow the arrow going across, okay, and lastly going down. How many conversion factor do we multiply by? This is the first one, this is the second one, and this is the third one, okay? So that's how you use the flowchart. Now I'm going to solve it right here for you. So we have 23 grams of what? Of H2, and we already know that this is A, you're given, and this is B, okay? And we are multiplied by the first conversion factor, which is this one here, 1 moles of A equals to grams of A, and that is molar mass. So what's the molar mass of hydrogen? It's right here, okay? So now on the AP Chem test or on a college test, they write your conversion factor like this. So that means you have to realize that. And sometimes they also write like this as well, 2.02 grams times mole of minus 1. They all mean the same thing, okay? So don't get tricked by it. So if this is grams, so down here must be grams as well. And this down here must be 1 moles of H2. And how do you know it's 1 mole? Because every time it's per means 1. So notice how gram of H2 got cancelled out, okay? Multiplied by the next one. What's the next one? It's the mole ratio. So where we get that from? Coefficient or subscript. Since we deal with a chemical equation, so it has to be coefficient. Here is what? Here is H2. And what's the other one? Ammonia is right here. So this is the coefficient right here. So how many mole of hydrogen do we have? We have 3 mole of hydrogen. And how many mole of ammonia do we have? 2 moles of NH3. Okay? There you go, and this got cancelled out. See how that works? We just multiply one conversion factor at a time. And this is the last one right here. In this case, notice how we have B now, right? B is ammonia. So what we have here is what? We have mole. So down here, we look at this. So the 1 moles of NH3 has to be on the bottom. And the top part is 22.4 liter of NH3. And this only worked because it's at STP. If it's not, then you have to figure out another way using PV equal nRT. But that's on later topic. Now let's continue, okay? To do the math, you just multiply everything on top. So 23 times, I'm going to put parentheses everything top, times 2 times 22.4, okay? And you are going to divide everything on the bottom. 2.02 times 3 times 1, but we can ignore the 1. And then we are going to get our answer. So let me bring out my calculator. So if you notice, we have parentheses. So this is what you are going to do. You are going to use parentheses as well. 23 times 2 times 22.4 parenthesis, and then you are going to divide, and then you are going to parentheses, okay? Parentheses is another way to group number together. So 2.02 multiplied by 3 parentheses. And if you're using a regular calculator, just divide directly. But here we're using decimal. Now the answer is what? 170.03. So we have 170.03 liter of NH3. And that is our answer. So as you type in your answer, of course, you will only type in that number. And that is how you use the flowchart to solve any stoichiometry problem. Just remember, the conversion factor are represented by the arrows, okay? And as long as you follow the arrows you get from your given to your unknown, you will never get a wrong answer. And as you practice this type of problem throughout the year, you become an expert at it, and you will remember this forever.